Swayam Prabha. Digital India. Educated India.
So, hello everyone, today I will discuss about the cell adhesion. So, in the last lecture we discussed about the cell surface interactions, then we discussed when an implant biomaterial comes into contact of body fluid, the sequence of event we discussed: surface water interaction, surface protein interaction and the cell surface interaction. So, in the cell surface interaction, the very first step was the attachment, or you can say adhesion, followed by cells growth and proliferation, then differentiation. So, when we go for some implant or surgery, so there are host cell response. The host cell response comes from the two factors. The first factor is the injury and second factor is the material. So, injury means it is like a surgery, so it goes with the bone healing process, and material, it depends on the whether it is degradable or biodegradable materials. Accordingly, that duration of host cell response or you can say inflammation continues. Then you discuss what are the different complement pathways which trigger the host cell response or you can say foreign body reactions. So, we discuss the classical pathway, lectin pathway and the alternative pathways, and in all three pathways they trigger or they activate or you can say they end up in inflammation, lysis and opsonization. Then we discuss what are the different sequences of response. The first step is the injury, then blood material interaction, followed by that provisional matrix formation, then it goes to the acute inflammation, then it goes for the chronic inflammation, followed by that foreign body reaction, then fibrosis. So, these were the sequence of responses during the foreign body reaction or host cell response. Then we discuss briefly what are different factors, particularly the physical and chemical properties of the materials, how it affect the host cell response or the cell surface interactions. So, in today's lecture we will particularly focus on the very first step of the cell surface interaction, that is the cell adhesion. So, we will discuss what happens during the cell adhesion, how it is mediated, which are the receptor proteins which participate in the cell surface interactions. Then followed by that we will just see what are the different intermolecular forces which regulate the or you can say which are involved during the cell surface interactions. Then based on the intermolecular interactions or you can say interfacial tension, can we comment on the when there should be the cell adhesion and when there should not be the cell adhesion, means we can comment on the gives free energy or the work of adhesion. Then followed by that we will simply see can we model the kinetics of cell adhesion. So, for that we will just see from the experimental data what information we can extract, and that can be used for calculating the rate of adhesion or you can say the rate of initial rate of cell attachment. So, as I told, the first thing is that this is your implant This is your surface. So, we are going to have this water molecule, it will reach depending on the diffusivity, followed by the protein molecule, then cell will come. So, the cell surface interaction also it looks like the protein surface interactions. Cells are having the outer layer like a cell membrane. So, basically the cell membrane and the outer layer of the surface they interact. So, the cell membrane participate in the adsorption, secretion, transport and communication, or you can say the cell signaling. So, due to the interaction between the outer surface of your material as well as the cell membrane, these are the steps. It starts with the attachment or adhesion, and depending on the nature or kind of adhesion, it decides how the cell grows, how it is spreading, its proliferation, then its finally differentiation. So, whenever there is a difficulty in the attachment or anchoring with the surface, in that case the cell surface interaction does not take place, yet it leads to the, you can say, the apoptosis of the cells, which is undesired, especially for an implant biomaterial. So, as I told, the adhesion of cell, it is modulated by the cell surface receptors, and these receptors are basically proteins which are embedded in the membrane. They communicate through the protein for the attachment, or you can say adhesion on the surface. Now, if there is a interaction between cell surface, so there can also be the interaction with the cell and cell surface. There can be both the interaction. There can be the cell interaction as well as the cell surface interaction. So, in general, this extracellular matrix participate in the adhesion process. So, cells attach to the extracellular matrix through the adhesion receptors, and this extracellular matrix binds one into the surface and other into the cell. So, in this way cell surface interaction take place. This is one example. So, particularly what happens, as we know, these cell surface receptors are the protein, extracellular matrix have the number of protein. So, basically the binding is very specific, and the specific peptide sequence participate in the binding, or you can say, in other words, the binding sites participate in the binding of the protein. So, cell C is going to have the cell surface receptors. Many times they also secrete various proteins to facilitate the cell adhesion process. So, during the cell adhesion, there can be the three types of adhesive sites, or three kinds of cell adhesion. First is we call the focal adhesion. In this case, the distance between the cell and surface is about 10 to 20 nanometer, and these are facilitated by the adhesive protein. Adhesive protein, like one example is the fibronectin. The second is the close contact. So, its range is 30 to 50 nanometer, and basically it surrounds to the focal adhesion points. And third type of adhesion is the extracellular matrix content, and its contact range is greater than 100 nanometer. So, basically in that case you are having a cell, then this is the ECM component, and then it connect with the surface. So, ECM components connect to the both side. One side it attaches to the surface and other side it connects to the adhesion receptor or cell surface receptors. So, these are the three: focal adhesion, close contacts and the ECM contacts. Now, as I told, ECM is a network of, or you can say this is a mixture of various proteins and other macromolecules. So, it mainly includes the collagen, different enzymes, elastin, other glycoproteins and the proteoglycans. So, these are the, you can say, the major constituents or major components of the ECM. That is why the ECM has a different role starting from the cell attachment, its orientation, due to the presence of its constituents like collagen, different enzymes, elastin, glycoprotein and the proteoglycans. So, because of its constituent, it plays different roles which are very important, particularly for the cell surface interactions. So, typically what happens, these microfilaments in the cytoplasm. So, they are made of, or they constitute actin, myosin, actinine and the tropomyosin. So, they are connected to the cell membrane via the integrin structure, and then these microfilaments, one side they are connected to the cell membrane via the integrin structure, and then other side they will try to communicate with the surface. So, as I told, especially in case of the focal adhesion, we will have different adhesive proteins like laminin, the fibronectin, they participate in the, or you can say they mediate the cell surface interactions. So, as we know, there is a important role of proteins. So, many times we go with the pre-adsorbed proteins. You can further correct the pre-adsorbed adhesive proteins. So, we pre-adsorb the adhesive protein to facilitate the quicker cell surface interactions. Also, proteins are also secreted or produced by the cells, and depending on the presence of these proteins, either pre-adsorbed proteins or the protein produced by the cells, this governs what is the strength of cell surface interaction and what kind of cell adhesion will take place, whether it will be the focal adhesion, close contacts or the ECM contacts. So, basically cells are having the cell membrane which participate in the adsorption as well as secretion of proteins and the communication, and these are regulated through the cell surface receptors, or you can say adhesion receptors, and these adhesion receptors communicate either through the focal adhesion or the close contact or the ECM contacts. So, what are the different type of cell adhesion molecules? So, if you just see, there are 5 principal classes of the cell adhesion molecules, starting from the cadherins, then immunoglobulins IgG, then mucin, integrins and selectins. So, these are the 5 principal classes of the cell adhesion molecules, we also call CAM, yes, cell adhesion molecules. they participate in both cell as well as the cell surface interactions. So, you just see in all the cases they are connected with the, especially if you just see integrin, it is connected with the fibronectin, that is the cell adhesive protein. So, in this way they, and especially if you just see the catherine, they are having the calcium binding site, and basically the calcium binding site or the presence of calcium regulates the activity of the cadherins. So, these are the 5 classes: cadherins, immunoglobulins, mucin, integrins and the selectins. So, now as you know, this integrin majorly take part during the cell surface interaction, or you can say the cell signaling pathways. So, even it is connected with the adhesive proteins, also it is connected with the, if you remember, this microfilaments which are made of the actin, myosin, actinin and tropomyosins are connected to the cell membrane by the integrin structure. So, integrin play a key role during the cell adhesion process. So, we will quickly see how this integrin works. So, basically integrin is a heterodimeric compound which is having 18 of the alpha subunits and 8 of the beta subunits. They combine together to form the 24 distinct heterodimeric integrins, and these heterodimeric integrins mediate the attachment of the cells to the ECM components, and ECM components is different proteins. So, we will quickly see here. So, basically there are the 8 beta subunits, so beta 1, beta 2, beta 3, beta 4, beta 5, beta 6, beta 7 and beta 8, and accordingly there are different combinations of alpha and beta. So, alpha 1, alpha 2, then alpha 1, alpha 2, alpha 5, alpha 8, alpha 3, alpha 6, and so there are some alpha L, alpha M, alpha X, alpha D, and apart from that there are other like alpha 2B. So, in this way there are 18 alpha subunits. So, they combine with each other to form 24 distinct heterodimeric integrins, and now you just see this alpha 1, alpha 2, alpha 10 and alpha 11, they participate or they are the collagen receptor, and collagen is the part of ECM matrix. Now, alpha 3, alpha 6, alpha 7, they are the laminin receptor. Similarly, this alpha 5, alpha V, alpha 8, beta 8, beta 6, beta 5, beta 3, they are the RGD receptors. RGD means arginine, glycine, aspartic acid. So, this is a peptide sequence which is found in the various adhesive proteins, and particularly this sequence, or you can say integrin bind to this particular RGD sequence, and other are the, let us say beta 7, alpha E, beta 2, they are the leukocyte specific receptors. So, you can say the integrins, depending on what type of its heterodimeric structure is available, it can bind to the collagen, it binds to the leukocyte like receptors, it binds to laminin, it binds to the RGD receptors. So, in this way the cell adhesion is mediated through the different chain of proteins. Now, during cell adhesion, typically if you see, the cells are slightly negatively charged and the surface may have the different functional group, especially if you are using the modified surfaces. So, in that case there will be different intermolecular interactions. So, very common is the long range interactions like the van der Waals interaction. Other, depending on the surface chemistry, or you can see the surface composition of the biomaterial implant, there will be different short range interactions that includes hydrogen bonds, hydrophobic interactions, you can say the acid base interactions. So, one example which is mostly discussed for the cell surface interaction or cell adhesion is the DLBO theory. So, it is given by the scientists who demonstrated this theory. So, based on their name it is given the DLBO theory. So, it demonstrates the relation between the particle distance, or you can say the cell distance from the surface. So, which includes, depending on the distance, it will have both the repulsive part as well as the attractive part. So, they have considered the attractive as a van der Waals interactions and repulsive as the electrostatic, or you can say the electrical double layer. So, they combine these two theory together and that is known as the DLBO theory, which demonstrate how the total potential vary with the distance, including both attractive and repulsive. So, attractive part is the, you can say the van der Waals interaction, and repulsive is electrostatic, in other way the electric double layer. So, depending on the different intermolecular interactions are taking place, it means there will be the role of work of adhesion, or you can say the potential or the Gibbs free energy. So, if you calculate the work of adhesion between the cell, particle and surface. So, particle means here we are referring it as a cell and surface. So, if you remember when we discussed the work of adhesion, spreading of B over A, it is, this is the spreading coefficient. Yes, is given as gamma A, interfacial tension of A minus interfacial tension of B minus interfacial tension of AB. So, if its value is less than 0, then we say it is a complete spreading. So, now let us consider the same concept for the cell adhesion. So, initially the cells are there in the contact with the liquid, now they are coming to the solid. Okay. So, here the SBA will be gamma cell surface interaction CS minus gamma CL cell liquid interactions minus interfacial interactions gamma solid liquid. So, we are having three interactions: cell surface, cell liquid and the solid liquid. And depending on the value of spreading coefficient, we should be able to comment whether this will be the spontaneous adhesion or spontaneous attachment or not. So, typically for, as I told, for the spontaneous attachment, delta G adhesion or the spreading coefficient, it should be less than 0. So, now you can see there is a role of gamma solid liquid interfacial tension as well as the role of cell surface interactions. So, now if you change the surface property, because we do not have much control over the cell's hydrophobicity of the cell. So, what we can do, if you want to tune this interaction, we can modify the surface. Here you can change the surface energy of your implant material or the implant surface. So, if you want to change it, so what we are going to alter? You can alter the gamma SL, you can alter the gamma CS, depending on the value of the gamma S. So, if there should be adhesion, means this value should be higher and this value should be lower. So, both the cases, if you are having the extremely hydrophobic surface, means the gamma SL will be lower, in that case this value may not be negative. Also, if you are having the extremely hydrophilic substrate, then again this value may be very high, in that case spreading coefficient may not be negative. So, we observed that extremely hydrophobic as well as the extremely hydrophilic, both the substrates, both the surfaces do not promote the desired cell adhesion. So, what we are seeing over here is, if you can tune the surface energy of the surface, or you can say that will going to alter the gamma SL and gamma CS, and in this way one should be able to see, one should be able to, you can say, control the adhesion or the wetting phenomena. Now, let us consider, if we are performing the experiment, then how we can analyze or we can say investigate the cell surface interaction. So, with time what will happen? The cells will be there in the bulk, they will come on the surface, we can capture the images with time, then one can analyze those images. And after analyzing, we can find what is the number of cells which are attached with time. So, that gives how many cells are attached. Also, we can see what is its morphology, means what is the area of the attached cells, what is its perimeter of the cells. So, it gives the information about the spreading as well as the coverage, means if the area of the cell is increasing, means it is a good spreading. Also, it will give what fraction of surface is already covered. Then also we calculate the cell shape index. So, cell shape index gives the information that what is the degree of spreading, or whether the cells are in the circular shape or they are the spreaded. So, typically we consider cell as a circular. So, if its value is 1, so we are what we are doing is we are just dividing the area by the perimeter square. So, we are measuring the area, also we are measuring the perimeter square, and if you consider for the circle area is pi r square and perimeter is, let us say, 2 pi r. So, if you divide this, so area square upon perimeter square, sorry, area divided by perimeter square, so it will be pi r square divided by 4 pi square and r square. So, this will be the cancel out, we will get the 4 pi. So, perimeter is equal to the 4 pi times of the area. So, we simply divide 4 pi a upon p square. If its value is 1, it means the circle. So, what is desired is its value should be much lower than 1. It means it is forming the irregular shapes, or you can say it is spreading on the surface. As we discussed initially, if there is no attachment, so there will be no spreading. and that may lead to the cell death or apoptosis. So, based on the number of cells, if it is higher, we can say it is a better attachment. If area of cell is increasing, we can say better spreading, and also based on the cell shape index, we can say, we can comment on the type of, or you can say how good is the spreading, or you can say the growth of the cell on the surface. So, if its value is less than 1, it means it is growing, or you can say it is spreading on the surface. So, apart from the morphological analysis, we can also perform the biochemical analysis. As I told, there are various proteins are involved. So, if you can analyze those proteins, so the amount of those proteins indicates that there is a cell surface interaction. So, there are few like actin, integrins, also the, if you want to see the ECM proteins, one can analyze the ECM proteins. Even one can analyze the particular enzymes like the ALP, alkaline phosphatase. So, these are the different biochemical assays where we are particularly focusing, can we investigate or analyze what happened to a particular proteins. Also, we can stain the nuclei of the cell to just see what is the change in that nuclei. So, these are the different biochemical assays, and these are the particularly morphological assay, how we analyze the cell adhesion behavior from the experimental data. So, once we have experimental investigation or experimental data, then we can think of the kinetics of cell adhesion, because we are having the change in the data with time. So, what happens, you just see this, there are cells in the bulk, they will first come to the interface, and from the interface they will come on the surface, and then on the surface they will try to spread and grow. So, we just see there is number of cell in the bulk, they will cross the mass transfer resistance, they will come at the interface, and then at the interface they will interact with the surface, and then they will adhere or attach on the surface. So, we are having mass transfer coefficient, rate of attachment, and rate of cell detachment. So, similarly, based on this reaction, we can write the rate equation. So, dNs upon dt will be K into Ni into S minus Kd into Ns. So, as we are considering particularly the adhesion. So, adhesion means it is like a initial event. So, at the initial state we are assuming that Kd equal to 0, means there is no death, or you can say the detachment part is also ignoring for the time being, or the Kd value is very less as compared to the Ka. And also when we perform the cell culture experiment, the number of cells N0 is typically in the range of 10 to the power 4 to 10 to the power 5 cells per ml. So, in that case we can also ignore the value of Kf. So, where you can ignore the Kf is negligible. Okay. So, there is, we are assuming there is no mass transfer resistance. So, you can say Nb equal to the Ni. We have simplified it. So, it comes out to be the Ka, Ni will be, you can say the Ni plus Ns is equal to Nb. So, we can write Ni in terms of Nb and Ns. So, Ni will be Nb minus Ns into S. So, why we are doing this? Because Ni is not known to us experimentally. So, experimentally we know what was the number of cell in the bulk, and after the adhesion with time we are just monitoring what is the number of cell Ns with the time. So, if we solve this rate equation, we can analyze or we can determine the Ka, that is the rate of adhesion. So, this is simple first order kinetics. So, we will solve it. So, this will come out to be d theta upon dt is equal to Ka Nb into Ac upon As minus theta into Sf. So, here we are writing in terms of area. So, theta will be how this number of cell, what is the area of one cell divided by the total surface areas, that is the fraction, or you can say the surface coverage theta. This is the surface, the same expression we are writing in terms of surface coverage. So, number of cells into area of one cell divided by the area of the surface. So, this is the surface coverage theta. So, As is referred to the total surface area, Ac is the average area of the adhered cells, and Sf refers to the surface fraction available for the adhesion, because the rate will be proportional to the whatever surface is the left, because if you are considering theta means already some part of the surface is preoccupied. So, if we solve it, it is like a simple first order kinetics. So, we get the theta is equal to 100 into 1 minus exp minus Sf Ka into T. So, theta we calculate experimentally. So, experimentally we know what is the number of cells with time, what is the average area, and what was the, of course, initial total surface area was there for the experiment. Then if you fit the experimental data with this expression, so you can say that theta versus T, or you can say the ln, you can also convert into terms of ln theta. So, we can get the value of this rate constant, that is the value of K. So, in this way we have simplified here that because of initial number of cell, we ignored the value of Kf, and also during the initial adhesion we assume that Kd is much less than K, it is equal to the 0. So, we consider this number of cells, and number of cells can be converted also in terms of surface coverage. So, it is like a first order kinetics. So, it is getting the simple exponential function. So, if you know experimentally what is the surface coverage, what is the number of cell with time, area of the cells, we should be able to calculate the rate of adhesion. So, here I conclude this lecture. So today we discussed what are the different cell surface receptors which participate in the adhesion of the cells, and depending on the availability of that receptor molecules, that can be focal adhesion, close contacts, or the ECM contacts. Then followed by that we discuss what are the CAMs, cell adhesive different molecules. So, we discuss the 5 principal classes of the cell adhesive molecules. Then we briefly discuss how the integrin works. It has 24 distinct morphology, or you can say 24 heterodimeric structures which participate in the binding of the collagen, or you can say the RGD PEP motifs, or laminin, and the leukocytes. So, basically there is a intermediate adhesive proteins which may comes directly from the pre-adsorb proteins or secreted by the cells. They connect with the integrin and integrin connect with the cell. So, this is like a communication between the cell and the surface. So, once there is cell adhesion, so we can also tune the cell surface interactions by changing the surface energy, or you can say modifying the surface energy, because we can tune the spreading coefficient or Gibbs sphere energy, because the cell surface interactions is governed by the different intermolecular interactions. We discussed the short range and the long range forces, and one particular case we discussed the DLVO theory, which considers both attractive van der Waal and repulsive the electrostatic or electrical double layer forces. Then we discuss from the experimental data how we analyze the cell surface interaction, particularly in terms of number of cells, average area of the cells, cell shape index, and different biochemical assay like actin analysis, integrin analysis, staining of the nuclei. Then from those experimental data we can investigate the kinetics of the cell adhesion, particularly number of cells, or you can say the surface coverage, to calculate the value of rate of adhesion. Thank you.